Hi, I'm Dr. Fara Kamangar. We are at the SF Derm Eczema Symposium and 100-year celebration, and we're joined by Dr. Roxana Daneshjou and Dr. Tofunmi. I'll have you say your full name to me again in a second so I get the last name right. And I'm so excited to have you both. Thank you guys so much for joining. You're probably on a very busy day, so thanks for taking 15 to 20 minutes of time. And I really am so excited to hear about what you guys are doing. You're doing some amazing work over at Stanford around AI, dermatology. So Roxana, I'll let you feel free to add introductions for the both of you and just the project that you're working on.
Yeah, so I am an incoming assistant professor of biomedical data science and dermatology at Stanford. And I spent a good portion of my time doing AI research. I'm also a board certified dermatologist. I see patients half a day a week. And I'm here with Dr. Tofunmi Omiye, who has his MD and did a master's in public policy at Stanford, but is actually his superpower is being able to do AI research. So he has been doing postdoctoral studies with me on looking at this new thing in AI, which we call large language models. You may have heard of some of them like Chat GPT, and kind of looking at how these models might work in a healthcare setting, what some of their biases might be. So we're very excited to be able to talk to you about this, I think, really hot and exciting topic.
That sounds great. Now, thank you both for being here. And then 4 to 5, we actually have a media panel here too at the conference. We're going to be talking about a new version of generative AI. So I'd love to talk to you guys about that afterwards too, because I think it'll be right up your alley. But first, just to start, do you guys want to just tell me a little bit about maybe the most recent things you've been doing, or any background, any current projects?
I mean, I think you really need to hear from Dr. Omiye about his recent preprint, now under review. It actually went pretty viral on social media. But I'll let him talk about it.
Okay, yeah. Thank you, Dr. Daneshjou. So, one of the recent stuff we looked at was for the range of publicly available large language models, so Chat GPT, GPT-4, and there's also Google's Bard, and there's another one called Cloud, which is from Anthropic AI. I would try looking at how they would work in the healthcare setting, and the motivation for that was we saw that GPT-4 was already getting integrated into electronic health records, and some medical schools already testing it out, and some hospitals. And we started to look at how those models, do they propagate race-based medicine? And what we did was prompted them and asked them questions about things that already been refuted, like EGFR calculations, so skin thickness in black and white people, or even like gender biases. And the interesting thing is that these types of work, like bias types of work, have already been done a lot in the computer science literature, especially from the point of social and political biases, but very few has been done in healthcare. And we saw that many of those models actually propagate race-based medicine by continuing to recommend things that have already been refuted. And I guess the takeaway for us in that paper was, as we're getting advanced in all this technology and we're moving forward, is there also a way in which we're also going backwards in the aspect of clinical care, especially when these things are being integrated? And the main message was to researchers and even administrators that are trying to implement some of those models to be careful, kind of like just put them through rigorous evaluation processes before they are being deployed in healthcare settings. And that's pretty much a broad summary of what we did there.
That's amazing. It's amazing work you're doing. And where can we find, where was it posted, where it went viral? Where can everybody find that so we can read all the comments?
Oh, yeah. So it's on medRxiv, but it was viral on like Twitter and, shared a lot within the ML community. I would say one thing that's interesting about being in this particular space is everything moves so quickly that again, as I mentioned, our paper is undergoing peer review. We're in the middle of the peer review process, but in machine learning, everyone posts preprints because the peer review process is much slower than the life cycle of the research that's actually happening in this space. And I commend Dr. Omiye because, as he mentioned, this is actually one of the first early studies particularly looking at biased behavior in healthcare, that behavior has been noted in the social sciences and such.
Yeah, that's amazing. And Tofunmi, I'd love to hear your background. What got you interested in AI? I know you're from the medical background, MD. What kind of led down that path?
Yeah, it's very interesting. So I trained as a medical doctor from Nigeria, and during COVID, I was working as an intern. It was crazy times in Nigeria. I did some of the first early research on COVID on the continent then. But then I really started to think about how I can help to improve healthcare access. I started to think about the triad of healthcare. So it was access, cost, and quality. And I felt like technology was probably the most efficient way to, number one, increase access, improve the quality of care that people get, and also reduce the cost. And in the aspect of technology, I try to optimize again for the most efficient form of technology that could do that. And AI just came up to me as probably the most obvious answer. And I'd always been interested in technology from a very young age, like since high school, I've always been interested in and fascinated about it. So I felt I could merge those interests into trying to do that good and solve those problems around the triad of healthcare, access, cost, and quality that I identified. So after that, I started taking a lot of classes and just, kind of spending a lot of sleepless nights to understand how it's done and how it can be applied to healthcare. I felt like I could also take on my clinical background, be at the intersection of AI and healthcare and be able to bring unique perspectives to that space.
I love it because I was an engineer as well before I became a physician. So I like everything you're saying, like we need to talk about this in much more detail at a later time because there's so many degrees. There are like MD, JDs, there's MD, MBAs, MD, MPH, lots of different degrees. I really hope eventually we develop some of these MD engineering type of degrees because I think the people who are going to make a difference, and technology is the future. I think the people who are going to make a difference are people like you that, really, but there's no path. I'm sure you kind of had to, like, after you found your interest, you had to kind of find things to do. But I would love for those paths to exist because I think these doctor first projects are looking at things that maybe these programs aren't looking at. Like you're looking at this very specific thing that's so interesting. Because if it's biased, how helpful is it? Yeah, I think that's so great. And just some general questions. Maybe we should just for the audience, anything you'd like to talk about with just generally how are large language models developed? If any issues with the models, or what were the main things that you kind of found when looking into it?
So I'll just talk about the development of large language models, and that's something we found is extremely important for the medical community to know, because if you don't understand how something works, everything just becomes a blur. And I'll just try and describe it in 3 steps, just 3 very simple steps. So the first thing is to understand the idea behind these models, which is they are just some types of AI models that were trained on large amounts of data. And large amounts of data simply means things like the Reddit post, Twitter, or like Wikipedia. And you imagine like there's so much of that data that's been generated over the past like decade, really, even more than the previous decades of human history. And we have all of that on the internet, and all these companies have access to that. And they have those very complex models that they could train on those types of textual data. And the goal of this first stage is really to predict the next word. So it's like, imagine a toddler is growing and the toddler understands when you're saying, baby, come, like it just starts to understand, okay, when you say baby, you want it to come, right? And starts to act that way. And really that's the goal of that first stage, right? And then we create something we call, it's just a base model. It doesn't really do anything. It's not like Chat GPT. It's not as powerful. The second stage is when they start to they call it the fine-tuning process and like machine learning speak. But what really happens there is that they now start to get trained on more narrow data sets, which could be a situation in which maybe people start to train it on medical data sets or like something on WebMD or just those types of more medical things. And then the third stage is the one that produces the Chat GPT, which is where it's a very human-intensive process. And in that case, they would contract like people from different parts of the world, and they would ask this model questions like, oh, what would you do in this particular situation? Or generate a poem in the style of these, or generate a drama in the style of Shakespeare and all those types of things. And they would say, okay, this is wrong, this is right. and the model starts to learn what is right and wrong. And again, think about it when you're training a child and you tell you don't know, you don't eat dirt, or you don't talk to people like that. This is how you talk to people, and then it starts to learn those things. And really eventually it goes through those 3 stages. It's very complex, but just try to break it down. And that's why I'll get the Chat GPT and all those types of language models that are available right now.
Yeah, no, I agree. It's so important just to understand it, because I think it's so new to a lot of people. How do you both think it can best be used in healthcare, or just even like top 3 ways you could see it being used in healthcare? Like, what do you think are the best practices for AI?
Yeah, I think, I thank you for that amazing explanation of how the models work. And I think when you get this explanation, you begin to understand a couple of things about behaviors of models, which I just want to talk about before we talk about the healthcare use cases, which, as Dr. Omiye mentioned, the first stage is you train to kind of predict the next word. So that's not training on any accuracy of making sure that the information that it's learning is correct. It's just learning, relationships between words. And as he mentioned, in the later stages, then you have human feedback. But it's not like they're getting human feedback from physicians. It's not physicians who are going in. And so what ends up happening as a result is a model, and I think a lot of people who have played with Chat GPT have seen that it does these what's called so-called hallucinations, where it makes up references. Well, that's because it's thinking, okay, what a reference is, maybe it picks the most common name that it sees in a reference, and then what is a common year that shows up after that. It hasn't actually learned the reference itself, or it'll say things as found in our study that is inaccurate, race-based EGFR, and it'll even explain why it's using race-based EGFR based on things that have been thoroughly debunked, like saying that there's muscle mass differences between races, which is absolutely untrue, been refuted. Race is a social construct. Just to bear that in mind, and then we can maybe talk about the top 3. But I'll let him start with his top 3. But I think that background is important when you're thinking about, okay, now I understand how these models were trained and what their limitations are. Now let me think about where it might be the safest to use these models.
No, absolutely. It's so important just to understand the pitfalls too, right? Before it's adopted generally, which is why it's so important, the work that you two are doing. Because there's not a lot of people doing this type of work as well. So it's so nice that you're actually spending the time to find where the problems are and how they could kind of multiply down the line. So, but yeah, no, go ahead. And it doesn't have to be exactly 3. It could be any top uses you see for any.
I guess the three main things I think about also is, I guess one is clinical care, the second is medical education, and the third is administrative. And if you think about medicine, apart from research, just core medical practice kind of really goes around those 3 prongs. And in the aspect of clinical care, because these models are good at generation, so you can think about patient education tools, but of course there has to be a human verifying the accuracy, like Dr. Daneshjou has mentioned, how they could really bring out this inaccurate outputs and even say things that blatantly wrong. But they are good at just explaining things in a way that would make sense. There's this popular thing on Reddit when ChatGPT first came out, where they would say, explain like I'm 5, this complex concept, and it's able to break it down and use maybe a small game or toddler game and stuff like that. So I think that's one part that is really good in the aspect of being a chatbot and just explaining things to patients. And there's been a lot of studies also showing that sometimes patients prefer that ChatGPT generated content compared to what the clinicians do, which makes sense. The second aspect is also medical education. You can imagine them generating just tons of board questions. Just imagine you have this assistant that can generate hundreds of board questions, testing a particular concept in many different ways, and you can ask someone to just look at, okay, is this accurate or not? So I think that's another part.
I can actually imagine that. We'll chat about that later today, but go on.
Yeah. And the third aspect is administrative. So we all know medicine, healthcare in the US, everywhere in the world, there's a lot of administrative burden, which is contributing to significant burnout, and even the pandemic exacerbated that. And you can imagine these models as really helpful assistants where they could generate drafts of letters for insurance authorization, or even some of the mundane documentation tasks like summarizing things, they could just, generate that and be very good at cutting words. Sometimes very good at you put maybe 1,500-word essay and you say drop it, reduce it to 100 words, and it will try to do that. And you can imagine just generating medical summaries, discharge summaries, and some of all those other administrative documentation tasks that most people do not like. So I feel like it could do a lot of that. So those are the three things I generally think about when I'm studying these things and also just reading papers about it.
That's amazing. Dr. Daneshjou, anything you'd add? Any other use cases that?
Yeah. I think, the caveat, which she said beautifully, was that you really have to check and be aware of automation bias. And so, and the other thing, of course, the other caveat is that unless you're using the specific plugins that plug into your electronic health record system, which some places are doing now, there's no these are not HIPAA compliant systems. So please do not put protect health information in there. But like, for example, I've used it to generate first drafts of patient handouts on disease and then carefully edited it to make sure, as I said, sometimes the references are made, but it can make a really good first pass document. We've actually even used it to translate into different languages, and we did a study on that as well. We found that it doesn't behave uniformly across languages. It does better in some languages than others. And so you definitely need a native speaker to basically check and make sure that it's correct. But it really does help to have that first draft and not have someone have to rewrite it all from scratch. And so, I think there are a lot of different exciting opportunities to do this. But as was mentioned before, really, we have to do a lot of rigorous testing, which we haven't fully done yet and is still ongoing and still being piloted so that we understand the biases, the inaccuracies, because we don't want to worsen healthcare disparities. And certainly none of us in medicine want to do anything that could potentially cause patient harm.
Well, thank you both so much.